Welcome to Fantastic Math. This is Mr. V, and in this video we will factorize a quadratic expression by completing the square. So we've looked at different ways of factorizing expressions before, such as factorizing by grouping or factorizing by cross multiplication. The problems with those methods is that they really only work if there is a nice set of factors of the C term that will add up to create this B term. But what do we do if there is no combination like that? Well, that's where completing the square can come in really handy. We're going to start with this expression x squared plus 6x plus 6. And what I'm going to do for a moment is I'm going to just ignore the plus 6. And I'm just going to focus on this inner bit. Now, wouldn't it be nice if there was a way to factorize this without having to worry about what this term here was? One way to do this is we can try and make a perfect square. That will certainly give us a nice answer. But this expression is not a perfect square. So the question becomes, could we make it a perfect square? So if we're going to look now at this b term, so the term in front of the b. Now, if this was a perfect square, then we would have a bracket. We'd have a version of this where we would have x plus half of this term. So half of this 6 would be 3 squared. That'd be the perfect square solution to this. And if we were to expand it out, we would want something that has x squared, then we have double of 3 is 6x, plus the 3 squared, which is 9. That's what we want the expression to be to make this work. But our expression isn't. We have this plus 6. We don't have plus 9. So the way that we can work around this is we can add this plus 9. At the same time, we can take away that 9. Now that might seem a little bit weird, but this is doable. If we add something, we take it away, it's just like we didn't do anything at all. This is a little mathematical trick that we're using here. And then we're going to put back the plus 6 that we ignored at first. Remember that one? We decided not to look at this, and we're going to pretend that it wasn't there. Now we're going to put it back in. Now, all of this part, we know will factorize into the perfect square. We made it that way. We just got to deal now with this last bit. And that's quite simple. We can just simplify that. So we simplify minus 9 plus 6. We're going to get minus 3. Minus 3. And that is the simplified version of this leftover chunk that we had. And this is the factorized form of this expression, the x squared plus 6x plus 6. And we've done this by using a little bit of a math trick, by adding this 9 and then taking it away again. And it might be a bit hard to see. We'll do this again, and this time we'll go a bit quicker. Our second expression is x squared plus 2x minus 10. And first thing we're going to do is we're going to look at this b term, and we're going to halve it. So half of 2, so 2 divided by 2, that is 1. And so what we're going to do is we're going to expand this expression to become x squared plus 2x plus 1 squared minus 1 squared minus 10. That's our second step. We're adding 1 squared and we're taking away 1 squared. Then what we're going to do is we're going to take the whole bit that we know makes the perfect square, and we're going to make that the perfect square. So step 3, so we're going to factorize the first part. And that's going to become x plus 1 all squared. And then we've just got to simplify this remainder bit. So minus 1 squared is 1, so minus 1. Minus 1 minus 10 is minus 11. So we're left with minus 11. It's a bit hard to understand, perhaps, exactly how this all works, but once you just apply the method, it's actually a very simple way of getting to a factorized form of the expression. And that's it. That's how we can factorize an expression by completing the square.